Here we're looking at graphing a quadratic function as well as stating the information required of us for the graph. So I started out by graphing a standard quadratic which has a vertex at 0, 0, goes through the key points 1, 1, negative 1, 1, 2, 4, and negative 2, 4. And that's going to be our starting point. We should have that graph memorized prior to the test. So the first thing we want to do, we've talked about order before, and I look at the x squared, and the first thing I see being done to it is the fact that it has a negative at the front, which tells me the graph has been reflected across the x-axis. So the key points that I have on the graph in black, I'm going to now reflect those points across the x. 0, 0 remains the same. 1, 1 becomes 1, negative 1. Negative 1, negative 1. And then also I'm going to do the same thing with 2, 4. So it becomes 2, negative 4. And negative 2, 4 becomes negative 2, negative 4. I can draw my graph. And because I'm using different colors, I'm doing this one in green. My final graph is going to be in red. Normally on a test, you would probably dot this first transformation. The second transformation is the positive 4 at the back end. Now we should know from doing graphs already that because that 4 is after the x squared, that is a vertical translation 4 units up. It's not inside brackets with the square on the outside, so it's not a horizontal translation. So all we're doing is taking the green graph and moving all the key points 4 units up. So 0, 0 becomes 0, 4. We take the point at 1, negative 1, move it 4 up to 1, 3, and the same thing on the other side, as well as the points at 2, 4, and negative 2, or 2, negative 4, and negative 2, negative 4, come all the way up to the x-axis. And so our final graph would look something like that. Very important to remember to put our arrowheads on the ends of the parabola. So from this graph, I'm going to start setting up my information. The first thing that they asked for, and I've abbreviated these, is the domain. Now the domain of this graph represents the left-right behavior of the graph, and in this case, this graph is opening up on the right side and the left side to both negative and positive infinity. So in interval notation, I use negative infinity to positive infinity because the domain should always be read from left to right. With the range, we want to be careful here because the range of this graph should be read from the bottom up. So the lowest point on my graph is an arrow going to negative infinity. And the highest point on the graph would be reached at this point, which is a y value of positive 4. And I'm going to square that off, signifying that the graph actually reaches 4 and goes through that point. The vertex is the turning point of the graph. And if I mark this in blue on my graph, my vertex is right there, which has a value of 0 for x and 4 for y. The y-intercept, again, what I want to do is look at the graph, and my y-intercept is at the same place as the vertex in this case. It's not always that, but in this case, the graph goes through the y-axis at a y value of 4. It's important that we put y is equal to 4, not just the number 4. And my x-intercepts occur at two positions on the x-axis, and those values are plus 2 and minus 2. So I'm going to write that as x is equal to plus or minus 2. The max-min represents either if the graph is going down or opening down, it would be the highest point of the graph would be a maximum. If the graph is opening up, it would have a minimum at the lowest point. And those points always coincide with the y value of the vertex. So in other words, my maximum point, because this graph goes up, I would circle max. And the y value is where the blue line I have drawn in would be at y equals 4, which is the y value of the vertex. The axis of symmetry is an invisible line that divides the graph into two identical looking parts. And so in this case, with a parabola, x squared parabola, that line is always going to be a vertical line. So I've put in a purple line here that represents the axis of symmetry. It takes my red graph and divides it into two parts. And the equation of that line always coincides with the x variable, or the x value of the vertex. And in this case, our x value of our vertex is 0.